Okay, it's recording. Yep, it's recording. And camera. You guys see? Oh, it isn't. It's HD camera. Can you guys see?
I don't see anything.
Huh. It opened for a second. Okay.
Oh, there
You
it
guys-
is. Yep.
So can you guys see the table?
Did this light open? It's not above us?
Yeah, I was trying to turn that light on and stuff. You guys see where I'm right here? I was doing this before, but all right.
It
Yeah,
looks
we see.
good.
Chapter 1.
Is that better?
Is it better? I won't be able to read the chat, by the way.
Yeah, it looks good.
Oh, that's the transcript. I thought it was a chat. Okay, grammar, sets, grammars. So let's go to so first we're doing sets. So if you wanna say if X is an element of big S, you can say it by saying X is an element of X. And if it's not, it's going to be very simple. How down did I go?
You got more time. That's it.
Okay, right.
That's pretty good.
And we also need to know or should know what a universal set is. Just say U, capital U, and an example of it could be so everything in a set, in a universal set. So any like kind of number or symbols, anything can be included in this universal set in a capital U. You guys probably have this, but I'm just going through like little by little. But sorry if I deleted from the bottom. I should have done it from the top. But then next I'll go to the union and intersection. I think this is important even for chapter 2 or 3, I believe, when union is included. So when S1 union S2, well, if you can do union S1 and S2 are sets first. How else we can write this is by saying X an element S, or and then for the intersection, it's 1. This is 1. Just include and instead of or for intersection. This is kind of like important to remember. For union, it's or, and then for intersection is and. So when you build like the machine, And then the language says something just like in the homework, for example, like L is equal to A3 or union. Something like B to M plus where N is bigger equal than 1 union or A5. So this one kind of like dictates how you're going to build the machine, basically. You can do or, and then the machine will look different. And if you do intersection, the machine will look different. We still haven't done the intersection. I don't know if we'll ever go through it, but they all look different. You will try to build the machine based on this one. It's kind of like the machine code with binaries like true and false or 1 and zeros. When you do 1 or 1 is equal 1, 1 or 0 is 0. Similar, but it's not exactly the same. And then S not. Yep. S not is X is element of the universal set. But then X is not part of S. There's also, I'm going to remove S union S2. There's also S1 minus S2, which I'm going to write it first and then talk about it. Great. I mean, it includes and. So if you are subtracting 2 from 1, that means like this element, but if this element X, let me hold this one as well. So for example, this element X, right? If it's in the S1 set, if you remove S2 set, then this X is not going to be part of it. Basically, this is how it goes visually. Like similar math, simple math. Next. Oh yeah, there's the phi symbol, which represent a null set. You guys, I don't think you guys are keeping this notes because you already have them, but I'm just going over it so we can kind of like
Refresh.
yeah, refresh and be prepared for anything that can happen in the midterm. But so a null set is used with a symbol, is defined with a symbol phi, which null set means basically empty. And the professor gave us some formulas, which, for example, some implementations of the null set. Let's say if we are trying to make S union the empty set, it's just basically going to be just the set. This is also equal to S minus the empty set. And for intersection, so it's basically, think of it 1, 1 and 0, right? In computer architecture or other classes that we took. So 1 and 0 is just going to be 0, right? So this is going to be empty as well. That's how I kind of like approach this. And also pretty self-explanatory. If phi has a knot on top, that would be equal to the set. Oh, sorry, universal set. Makes sense. And if you do double knot, which is basically be equal to just S. Next, I'll go over the De Morgan's law. So De Morgan's law says that if S1 union S2, then S1 naught it's intersect with S2 naught. And S1 union S2 all over, so like the whole knot, it will be S1 naught union S2 naught.
And it's supposed to be
Intersect, sorry.
intersect. And there's no knots, right? Or is there knots? For S1 and S2 where they intersect. For this first one, and don't remember.
There
No,
are.
the whole thing is.
The whole thing is supposed to be intersected?
Yes,
Okay. Oh, well, I probably missed that my notes then.
maybe I did, but well, let's try to figure out, right? So this is or, this is and. So we are saying, well, in this one, we're saying, let's say if it's 1, I don't know if it will work, but let's try. Let's say 1 and 0, right? And 0 and 1. This both will be 0, 0. And it's everything is over naught, so that would be 1 basically. And for or, let's say we do the same thing. 1, 0, and this will be 0, 1, or it'll be 1 again. So it's kind of like true.
Okay.
It makes sense. This will help if you guys kind of like. That's what I'll do if I forget like the De Morgan's law. I'll just try to do it with zeros and ones. Kind of like just remember that union is equal to or, and intersection is equal to and. It's probably be very easy to kind of work with in the exam. And for subsets, there's also subsets. Much time do we have? Okay, we got it. I just don't know how fast or slow I'm going. So
Just going good. You're doing good, man. Keep going.
so S1 is as a subset of S. It's pretty self-explanatory. So let's say if S1 is 1, 2, 3, has these elements, then S will have those elements as well. But also, since S is a subset, it must
It must also be a subset.
must have other elements. Oh no, but it says equal.
Yeah.
So it can also have, it's not a must. So it can have it can be equal as just like the subset, or the subset can be exactly equal to the set. But also the set can also have, or the subset can also have 1, 4, 5.
Okay.
1, 2, 3, 4, 5. I'm gonna use red because I don't want the black marker.
That's right.
I won't be able to like,
Oh,
it will dry. Yeah, it will
okay.
dry. I won't be able to. And yeah, I don't know why I deleted that. I removed that, but yeah, it's, oh yeah, it explains it on the next one. I'm just looking at the notes. So let's say S1, right? Again, the same thing. 1, 2, and 3. S now S cannot be S1 cannot be 1, 2, 3, 4, 5 because the sign of that includes here, it doesn't have the equal like the underline. It just says that S1 is a subset, but this means that S must be like must have more elements or like other elements, and kind of like be make the S1 be a subset of itself. If it makes sense. There's also a disjoint set where there's no common elements. So let's say S1, S2, and 4, and then S has 5, 6, and 7. So these are disjoint. This is a disjoint set. This is 0. It's join, not join. uh, Can also do this.
Is that cross product? Or just multiply?
I don't think there are.
Cross products there?
I don't think there's matrices. I think they're just multiplication. If it's matrix, I believe so. It would be called cross product. But let's say it's just S1 times S2. I'm not sure, by the way. So S1, S2, let's define or initialize S1 and S2. S1 is 2 and 3, and S2 is 2, 3, 5, and 6. So basically, it probably works just like cross product since the 2 well, it doesn't multiply with anything, just says it just makes it just creates this element, yeah, it just create other elements. So but this is probably like a new set.
Yeah, you're right. It's not it's not even close to the cross product. It's mostly
Yeah.
multiplication.
Well,
it's not even
multiplying.
It's
It's
just
just
when you're multiplying two parentheses. You know how in algebra, you have like 2 times 3i.
okay, mix. I understand what you're saying, but remember, like when we go to chapter 2, professor mentions that don't think of a to the power of 5 the same with a. So yeah, that's why I'm trying to like
Make a
not
difference.
not include it like that. So 2 goes to all the elements of S2 from the element 2 from S1, and then element 3 goes to all the elements from S2. So you're kind of gonna have the following, just like 2, 2, 2, 3, all the way to 6, and then for 3, 3, 2, 3, all the way to 3, 6. So functions and their relations is going to be the next one. You guys have any questions for this, or is have like more? You guys are familiar with it? If it is a yes, I think.
I'm all good.
Oh yeah. Taking time. What time is it there? 7:26. So functions and relations. We have to erase it.
Yeah, we didn't see it.
So much more. The function is the rule. So it just says what this does. It basically sets like a rule basically. And S is a domain of F, and S2 is the range of F. So it talks about the growth functions. Have you guys taken computer science too, and or what was the other one? Algorithms and designs? Yes.
Yes,
3110.
I think they're
So basic-
prerequisites, yeah.
So basically, like the growth function it goes over the time complexity, basically how like this function grows, or yeah, how this function grows or drops. I believe. Something important to note is that with intersection, or okay, I'm gonna write it. So wherever the function, and let's say big O or big omega, let's say this is f of x, right? And let's state that f of x smaller or equal than CG, right? And if f of x is in well, it's not but is in of g of x, what this means is that they will like intersect, like the point of the intersection between like this point over here between the g of x and f of x is just going to be intersection basically. So of big O, it's trying to measure the time complexity of g of x, so like how this function grows. And if also to note is that that means that however this function is growing, if can I explain this? So let's say we have a constant and we have the function g of x, or the length of it, and the length of f of x is equal or bigger. Goes same for, can you guys see? But it's C, but the second constant of length of g of x. What this is basically what theta of g of x is. So this part over here is if it's f of x is smaller, it's bigger than g of x, the length, like the growth, then there will be like omega of g of x. And this one over here will be big O of g of x. And if those are, if this is how it happens, so like if it's omega and both theta, then both big O, then g of x will be theta of g of x. The other ones are graphs and trees. I don't think we need to go over them because we will just basically just be doing finite state machines, DFAs and NFAs. So it's basically what we're going to do in later chapters. Also, Professor meant the notes. I'm reading the notes right now, and there's also proofs. So it's proves by induction and contradiction. Pretty simple. I think I'll go over them. We'll not go over them. I'll go over the grammar now. We know what the alphabet is. An alphabet is basically like, yeah, like this is an alphabet. I don't know where I dropped it. Oh, yeah. Sorry, I dropped I dropped something. Yeah, let's go with alphabet and
Could you rewrite the alphabet somewhere else? Because the reflection of the light, I can't see it.
Oh,
okay, sorry.
No, it's okay.
Do you guys see here, like in this area, or
you see that?
No, we see it. Yeah, we
Here.
see
Where
it.
your hand is, we can see there, and where your other hand is slightly there.
Well, these
I mean,
two
in the
spots
middle,
you
there's
can't
all
see
light.
right here.
so here you don't see here?
Yeah.
Yeah,
right
yeah,
there.
yeah, yeah.
Yeah.
Okay,
That
I
reflection
see.
a little. Yeah.
Oh, damn. All right. Thanks for letting me know. I'll be writing there all the time. All this time. All right. So an alphabet is a set of symbols. So this is an alphabet. Because and the string could be anything that's inside the alphabet. So string S, let's say or string little s can be A, C, B, or A, B, C. But we also can have a empty string, which would be lambda. So just remember, guys, empty lambda is an empty string. And if we use the absolute like symbols, like two lines, two vertical lines between something, that means like it's the length of that thing. So let's say if we take little s, for example, right? And we do, that means that the s length is equal to, for this example, is ACB, which will be 30. The length of the lambda, by the way, is 0. prefix and suffix. So prefix is basically the front of the string, and suffix is the end. It goes over. I think these things may be in the exam. This one.
Yeah, I agree too. The suffix might be in it, most likely. That's prefix.
This is what I think they're gonna be in exam. Something like this. So let's say the alphabet of consists A and B. So
Oh, the powers you mean? You're talking about the powers?
yes, but they also like include 0, which is going to be lambda, stuff like that. They may be in the, then that's why I'm not. So the alphabet to the power of 1, which is going to be just basically A and B. The 2 is going to be A, B, B, A, B, A, and A, and B, B. And it will go the same thing for the next one. So it will just increase something. I think it will increase exponentially. So if we have AB to the power of 2 is going to be just four strings, 4 elements, 4 letters in the alphabet, I guess. And this one is going to be 8. So it's going to be A, B, 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 and so on.
Yeah, different combinations.
Yeah, different combinations. But to the power of 0, it's just going to contain the symbol lambda. So that means it will be just empty.
So it won't be that you won't be putting 0, right? You just be putting sigma language equals empty set.
I think you will put 0 because
0.
that's how you define an empty
I got you.
alphabet. I think if you just include if you say without the 0, that like the symbol is gonna wait. I'm thinking of like in the code, for example, if you do something, if you write something in the code, it will wait for like your explanation, what you're gonna put in there, it's just still waiting.
Right. So for example, in the parts where you put, like, for example, 3, you put like absolute, you put the sigma, the language 3 in absolute value and in brackets, and then you put like equals 8 possibilities, and that will equal to the power of 3.
Can you repeat it again?
Like this part. These are you see it.
So what that so
If it was like an empty set, so you put like similar to 0, how would you just put like equals lambda? That's what you would do.
so you're saying like this? This is sigma, by the way.
Yeah, that part.
Just remember, like I said before, like with a string, right? 1, 2, 3. It's it says the length of the string.
Yeah, like in the
It
string.
will just be 3. The length of the string, it still includes some.
Okay.
It just so it'll be 1.
I'll be 1. Okay,
Yeah.
that's right. I got you.
Because it's just values the length.
The length. Gotcha.
Yes. And it goes the same for the other ones. So let's say for the sigma to the power of 3, right? If we take the length of it, kind of think of it exponentially, right? It will be 8 of them. So just the length is going to be 8. And for this one, I believe it's going to be 4. So, oh yeah, it says right here. So to the power of n is just the length. Like of n, if we do this. And it also includes the star, the sigma star, which let's say we take in consideration that we are referring this sigma, we're referring with this sigma, right? So this star basically says that everything, every combination that can be between in this alphabet, including
Lambda.
lambda. Yeah. So A, B,
Will it also include lambda at the end too?
It doesn't matter the order.
Or it just has to be this is consistent?
It's kind of like an alphabet. It's a
Because I was thinking of like the language, you know, like like a language star, how we did like in the actual homework, how you have to have like lambda going from the final state and also from the beginning to the final state. That's what I was thinking of. Like,
yeah.
that.
I understand what you're saying, but I think that's different. We're calculating something else there.
Oh, okay.
We're gonna go there. We're gonna go eventually there. Hopefully, we don't run out of time.
I think we're almost done. Well, no, we still got something on a lot.
Now that I'm reviewing this, I remember the last lecture professor was explaining us. He also mentioned the plus sign last lecture. So now it makes sense that the plus sign will be the lambda star minus the sigma star minus the lambda. So everything just excluding the lambda. That's what the plus does.
Yeah. It's kind of like DFA that you could say.
Yes, that's why we're gonna like
That's what the
that's why we're learning them for, yeah.
Okay. That was good.
Oh, something important also that I want to add is for the language. Can you guys see here? Oh, I don't think you guys see here. I'll remove. You guys have everything? Probably you guys have it, so I'll just remove here. Get some space to write other stuff. So for the language, this is interesting. So for the language with a not sign, right, is going to be equal to sigma star minus the L. So everything excluding L, I think that means, this means that the alphabet can have any combinations, the star, right? So
Any combination of strings.
yeah, any combination of strings. So I think it's just going to be, oh yeah, explains it over here. Let's still refer to the old sigma, the old alphabet. And let's say that L, let's say the L star is equal to, it's going to be equal to lambda, AA, AB, BB, BA. Okay. So it was just, this L naught is going to remove the lambda and all the different combinations. Well, all the other ones that, but I have to read it again. So that makes sense. So the sigma, it's all possible combinations we can have. This is going to be our language. This means that everything excluding L. So this basically excludes L. So we're just going to subtract from this A and B, basically. And we're going to end up with A. Oh, now I get it. So we're going to end up with, we cannot remove lambda, by the way. Right. I don't know why in my notes I have it that we are removing lambda. Oh,
Yeah, I have it too. We have it removing lambda.
because let's say if the language contains lambda,
Then you
Then
have to
we're-
remove it.
yes,
Mhm.
yes. So if the language, let's say if the language contains lambda, right? Let's say this contains the lambda, so then it will just subtract the lambda from the sigma star. And it will subtract an, basically like I think it will subtract an A. Or like something like this and then a B. But
It's basically
since
just anything that's not in the language.
Yes, anything that's not in the language. Thank you. There's also this thing called language reverse. We'll go over that as well. And then I'll just continue with grammar. So this one is gonna be the last. So language reverse. It's simple. It's with L to the power of R, I guess. And this is a omega, lower omega. Where it's an element of L. Considering still the language, the alphabet is A and B. It will be equal to A, B, A, B, B, A, A. So it's basically a reverse. That's what it is. Language, if it has, let's say, L to the power of 2, it's going to be LL. So this is pretty similar to the alphabet. This is a plus. L plus, you guys see here? I don't think you guys see. Okay. It's okay. I'll just like,
No, you skipped that part. Yeah, right there, you're good.
okay, so L plus. L1 union L2 and 3 and so on. So just not include L0 basically. Because it's a lambda, yeah. Now I'll go to grammar. So contains the following grammar. I'm naming it with capital G. V, T, S, and P. V is a final set of variables. Meaning, I cannot put infinite there. It's finite. It's I don't know how to say it. It's finite. It's a finite set of variables. T is the set of terminal symbols. Okay. The S is the starting variable. And P is the production. Oops. This slide is so bad. I'm sorry, guys.
You're good. I can see everything.
So the product, the production rules, sorry, production rules. Let's say, for example, the starting variable is A and S, A, S, B. Also is lambda, meaning you can create a string. Well, it's a finite sets of variables, finite sets of terminal symbols. So I don't think you can go infinite with this. Well, theoretically you can, but probably like in a computer, just run out of memory or something. But let's say you can have A, B, because you can include the lambda here. You can just like put an empty and end it right there. But you can also like, it's gonna grow, let's say it's gonna grow from inside. It's gonna expand from inside. So A, B, B, the S is gonna be here, right? Unless you want to include lambda, and then it's gonna end it over here. But then again, you're gonna expand it from the inside, and it's gonna be A, B, B, B. That's how it works, basically. And the language for that is A of N, B of N, where N is gonna be bigger or equal than 0. So you can include as many numbers as you want, as many variables as you want there. And then you're gonna end it with lambda eventually. That's how grammar works. It will be helpful. It will be helpful for to build the machines later, or kind of like understand how to do that. I'll go over 2 examples, and then I'll go to translucent. Yeah, I'll do like, just because of the sake of the homework, the translucent graph or whatever it was called, it's in there. The homework 1, I believe. So I'll go over that. I remember some people were confused about it, so me included. Let's say the language of A n plus 1, B n plus 1, where n is bigger than 0. How we're gonna start is, all right, you want at least 1 A and 1 B in the beginning. That's how it's gonna start, right? So it will never be, let's say for example, it will never be A or just B, because n won't be, if you put n equal to -1, let's say, for example, if you want to make, it just doesn't go well with the language, basically. If you add this, if you make this 0, you have to make this 0. It doesn't make sense to. So we're trying to figure out the starting variable is going to be A and B, basically. So we start with A. This is a variable, basically. It will help us. It will help us get the language correct. So we start with A first, and then from that start, you can add. First, we cannot have B's in the front. That's how the language is. So that's why the starting is, we start with A, right? But then after that, we can also, like, we can include A, B, and then again from here, right? It's going to be A, B, and then A, B, AB or sorry, yeah, sorry, on the right. AB, and then the B's will keep going, right? But it's N plus one, right? This is just N, sorry. So we can have one, we need to have at least. Oh. Okay, sorry, I read this. So this is N, and this is N plus one. So in the beginning, we need at least one B, right? You can help us because we are allowed to put zero to include N as zero, to set N equal to zero. So for the starting, it's going to be A zero and then B zero. Oh, you cannot get it because you cannot see it. It's going to be A zero and then B zero plus one, which will just be B. So that's how we're going to start it. So it's B actually, it's not A. But now we want A1, B1 plus one, which will be ABB. So how we're gonna make ABB to work is by including another starting, another A variable, which is gonna create this loop. It's gonna create this loop of A is gonna increase, it's gonna be always like one less than B, right? We also need to end the grammar, so we also need to include that. You can also include lambda in it. Yeah, I'm just gonna make another problem like this and then go to the HN solution. Because we don't have much time. I just wanted to go over this because professor said chapter 1 is going to be included as well, so. Not as heavy as the other two chapters, I believe, but why lose points, right? So it says all strings with at least two A's. I think someone mentioned that we can do it by approaching it this way, right? Where A is going to be we are still referring, by the way, to the alphabet of A, B. So at least two A's, it's not going to be efficient enough. It would be much better if we include so if we do this, and then we set A to, I believe, either B or lambda. Oh, at least, it says at least. I thought it said exactly, all right. So we can actually include, it is B, lambda. That's correct.
Who's the one?
No, it's just like one problem that professor went over in the class.
Okay.
So it says all string with at least two A's. So this big A, this variable, it kind of like makes, think of it as a loop, right? That it never ends unless you add like a lambda to it. And you're trying to kind of connect what the problem is asking. So at least two A's, we want A's to be bigger or equal than 2. But we will start with 2, right? That will be the first combination. So A and A. And then we include the variables that create the kind of like this loop that you can go over and over, where you can include more A's because it says bigger or equal than 2, which we don't care anymore after that because it can just be as many A's as we want. But for the sake of our alphabet, we also need to include B's. So we include the B as well, and then the lambda to end it up whenever we want to end it.
Come on, for example, on the notes,
Yes.
they included first the variable a equals BA then lambda. How come you got the A out? AA. For the
This one.
Yeah, right here.
This one.
Second one.
This one.
Yeah, that one.
Or what do you want to know about it?
No, because the first I only put BA and an A, the lambda. How'd you get like the AA? Or did I miss something?
I think it should have A because think of it. It says at least 2 A's, right?
Mm-hmm.
So at least 2 A's means A is bigger or equal than 2, right?
Mhm.
So in the beginning, okay, the first combination that we want to make is
A.
2 A's,
Yeah.
right? So that's how we started. Starting variable, right? Starting variable.
Yeah.
Yes, that's how we start with 2 A's, right? And then this capital will help us. This capital A will help us kind of like loop over if we want more A's.
Yeah.
Because it says more or equal than 2, right?
Yeah.
But we also don't want to exclude B because B is part of the alphabet right here.
Hmm.
And then lambda to end it. If we want to do, for example, 3 A's, right? If you want to do A, right? You'll first start with A,
3 A's.
yes, A. The reason we put A's in between the 2 A's is because,
Those are the actual inputs.
no, because of the B. Well, yes, there are actual inputs, but because of the B,
Mm-hmm.
let's say you want to include one B in this string, right?
Yeah.
Which the string is AA. But your desires can be like you can have like 3 desires where you want to put B, right? You can put the B here on the left side, on the middle, or on the right side. So that's why you kind of that's why you include the A's. You don't
There is notified where the A goes, right? Because it's kind of like how on the state, they kind of like loop back to itself
not
entirely.
not where it goes. The A's are mostly like giving you the opportunities with all the possible combinations that the problem is asking you to do.
Mm.
So what the problem is asking you to do is give me a grammar where I can put B's anywhere I want, right?
Uh-huh.
But
That
there it has to be at least 2 A's.
Mm.
So what you are doing with the starting one, right? If you add another A, right, that would be wrong.
You have to have a capital letter ending.
Well, the reason it will be yes. Well, not just because of that, not just ending it with A, but there are 3 A's, right? But there you won't be able to have the opportunity to make the combination that has like you won't be able to make any combinations that relates with this type
No
of
way with it will be.
or with 2 A's. This is the most important.
Okay.
Most 2
I
A's.
just don't understand like why he only put BA and he didn't put the AA for that.
Why
Yeah.
did not put AA?
Yeah, why he didn't put it.
Why he didn't put it?
Yeah.
I don't remember if he did put it or not.
What do you have in your notes? Do you have
I have it that it's in there.
that's in there?
Yes, but I don't know why I should have done it alone, like not do it, not put it in there.
I don't know. I missed it again.
Do you guys have it? I'm talking about it's a problem called like well I just asked like, all strings with at least
2 A's.
2 A's, yeah.
No, this is all things with exactly 2 A's. I got.
Oh, that's a
I
different
think-
question.
That's a
Oh, the
different
different question.
But if you guys like have any issues understanding
Yeah.
any other problem that is similar to that, we can go over the homework for it.
Actually, no, yeah, I have the same thing as the professor. I was reading.
Oh, you were reading the other problem which
Yes,
says
sir.
exactly 2A's?
Yeah.
Yeah, that is important in exam actually. And the translution, yeah. Let me go to the homework and kind of deal with the homework first. So what the homework, well, we're talking about homework, problem 5 on homework 1. Problem 5, homework 1. Problem 5, homework 1. It says design a transducer to convert a binary string into a hexadecimal. It gives you an example there. So example is pretty self-explanatory, but you also have to remember that you need all the different combinations. You need not just that specific example. You will need all the combinations. So it says design a transducer to convert a binary string into a hexadecimal. So converting this binary string into hexadecimal, how are we going to do that, right? So we kind of like started with a tree where we give like different possibilities if it's either 0 or 1. So if it's 0 or if it's 1, it'll go this way or that way. If it's 0, it's going to go left. If it's 1, it's going to go right. And the length of this tree is going to be 3. The height of this tree is going to be 3. So 1, 2.
And you'll know the height is only because you actually completed it, right? Before. You just remember it? Or is it like a given reason why it's supposed to be 3?
It's
Because you-
because it says.
Because you figured out the answer, then you remembered, right?
Oh yeah, thank you for asking that. So the reason how we figure out the height is just by arriving, of course, but it's asking for hexadecimals, converting binaries to hexadecimals. So an hexadecimal, the way you write an hexadecimal is by having four nibbles.
4 nibbles?
4 nibbles.
Yes.
Or 2 nibbles. If 2 nibbles is equal to 8 bytes. So basically like just 16 bytes, right? So that's why you end up with the length of 3.
Oh, so if you have if you have 4 nibbles, you're gonna have 3 height. You have a height of 3.
No, it's big.
Like the problem.
Well, you won't be having 3 nibbles for the hexadecimal. It's probably if you wanted like in another.
No, for example, if I have 4 nibbles, will I have a height of 3? Or is it just depends on the
If
actual?
you want 4 nibbles, that means you will have, let's say, you'll have a decision of 0. Okay. Let's do it. 0, 1, right? And then 0. The height, I think the height will be the same. But like the length of it, like how many elements going to be, obviously it's going to be smaller. Now that I think it will be the same because how hexadecimals are written is like with letters. So we also have to know that hexadecimals are written in this form. So all the way to 9, and then from 9 it starts from A, B, C, D, E, and F, where A is equal to it's 10 and B is 11, all the way to F being 15, right? Or 16? I guess it's 16. Oh yeah, because it's 16 bytes.
Yeah.
Hexadecimal. Yes, 16, sorry. So how that like what the homework is asking you is even like trying to make all the combinations possible for each kind of conversion that you want to make from binary to hexadecimal. So how you can go through it is it's just writing the tree, just doing like decisions over decisions, right? So if you go to 0, you're still going to decide if you want to pick 0 or 1. And then if you go 0 again, it's going to be the same thing. 0 or 1. Professor told us to include lambda as well. The reason the lambda is important to include in this is because if you want to make this hexadecimal, like if you want to make this so this is 1, right? If you want to make this hexadecimal, if you want to turn this binary to hexadecimal, when you're going down the tree, right? You don't want
You forced
this value to be included as the result of your hexadecimal string. You want this last value here to be included. Only this, which will be 1. So
Gotcha.
and all far to the right, if you it will be the other opposite of it. So it'll be the 16. Because you're not including this, not including this. So you are returning
F is 16?
F. Should be.
Yeah, it should, yeah. One of the
But let's say you don't include you don't include you don't want to include F, right? In this part right here. You want to include 0 instead. That means when you are returning the value, it's just going to be like 1 less. So because we don't have much time, that's why I only like covered the left and right part. So, but think of it as this, on the right side of the tree, right? You are only choosing 1, just all 1s, right?
Mhm.
And then the other side is you're including all 0s. And then if you include just 1, and the last is going to return 1. But if you don't return anything, it's going to be 0, right? That's how it works basically. And if you include 2 1s, it's going to be 2 and so on. It's just think of it as binaries. I mean, yes, basically. Think of from the right side, right? It starts with F. And then all the way it's just going to decrease depending on the combination that you choose between 0s and 1. But it will, like these dots will always decrease all the way to 0. When you are structuring your like the tree by yourself, you kind of like you'll understand it much better. The reason I'm not going like fully into it because I don't have much time. Sorry, guys. But let's go to chapter 2. Like these are the problems that we are worrying about. chapter 2 or should we go chapter 3, the last problem that professor went over? It was remember that last problem professor went over?
No, the big huge one.
That crazy one?
The generalized transition graph.
Yes.
ECG. You guys want to go over that one too, or you guys want
Are
to?
you guys, yeah, do you guys want to go over the generalization? That's what it was?
The GTG, yeah, generalized transition graph.
Generalization
Yeah, we can do that.
transition. Okay. So. Let's go over it.
This problem wasn't in the homework that we're about to do, right?
No,
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 but it's going to
to be on the exam.
Yeah,
Yeah,
yeah, yeah.
I think chapter 2 is pretty simple. And if we are going like, if we know what we're dealing with in chapter 3, I don't think we've got to cover. We don't have to cover chapter 3. Just because sake of time.
I mean, even the homework for chapter 2 was just states, you know, connected to Q0 to Q1.
Yeah, that's what.
Yeah, it's pretty simple.
That's what I was.
The stuff on Q, yeah, exactly. Supersets of it. If you know chapter 3, you're gonna be good on chapter 2.
Can I see your
Notes. This is, I feel like this wouldn't start, wasn't it? And then,
This is the one, yeah.
yeah. This is the one I
Okay,
did.
I don't know why I did not write the language for it.
Because we were using it multiple times, that's why. That's why you probably just thought of it.
Oh yeah, you're right. Oh yeah, it's right here. Thank you.
You're gonna just use this?
I got it. I got it.
Okay, fair enough.
Okay, so the languages. The hard part of this is going to be
Translating the language, right?
yes to a machine.
To
That would be
machine.
like the top. This is going to be an exam sense also. So small omega is part of is an element of A and B, where N is and A even is an even. Wait, I think I'm reading you. I need to rush and I was doing like both of the notes. Okay, NA is even. Yeah. Okay.
Yeah,
I was
and
getting-
small lowercase n is even, and then a capital N is odd.
And then NB is odd, yeah.
Was it NB? Or was it NA again?
NB, no.
NB. Oh, NB? Man.
Yeah, you were screwing up, I remember, with that other person. It's okay. Remember we were
Oh,
discussing?
yeah.
Yeah.
I swear it was NA.
No, it was NANB. I remember this part. Now it's because I was laughing. I was laughing inside. All right. So anyway, so professor is writing EEOE just because of the sake of
Is this just a random? Or is...
understate. It's just even,
Oh,
odd,
okay.
even.
Ah, okay.
Yeah, which makes it much better to understand.
100%.
So we already know this problem. So why don't we go over if NA is odd and NB is even, right? I was trying to figure this out. So we can include the starting as even. I don't think what you start with or what you ended with really matters. Like the final state, what you include as a final state.
You think so? I mean, you're right, because all of the states have,
Yeah, it's
they all have empty sets repeating to each other.
but so we won't get confused. I'll still keep it the same.
Yeah, even odd. So if theoretically you think like if you put like the odd even as the final state, it will be fine. You think?
I think yeah. But the machine will be different, like when you do it, when you generalize.
Also, because all the outputs and then things they go to the same place. They look the
No,
same.
it will not be the, no, sorry, I was, well,
Think about this part.
the second step, yeah, the second step,
second
when
step,
you're
yeah,
gonna
of
move
course.
it, you're gonna, yeah.
Of course,
So
because you have
that
different
they- yeah.
values.
So NA is odd, right?
Yeah.
NA is odd. So that means
Isn't it NB is odd?
we are solving this other problem now.
Ah,
Because I remember professor said,
wait, well, for the language I put NA is even, NB is odd.
yeah,
What do you have NA is?
so we're just trying to solve this other problem.
Oh, it's different. It's not the same.
Yes, we don't,
Ah.
we already know how that works. So we're trying to
Gotcha.
figure out, we're trying to like help ourselves to build this
Yeah, build their own.
machine out of this problem, right?
Yeah. Use a, put a different marker.
Oh,
Like
yeah.
easier.
Yeah, I'm gonna use a different one.
I have other colors.
So for NA is even, right? For the last problem. It was, think of A was going over here.
Yeah.
I mean, this is a little bit tricky. So that's for NA's. This is for NA's even, by the way. Not odd. I'm just
Oh,
trying to like see and understand the patterns. Like,
oh,
what's going on.
okay. So I mean, right now with our questions,
So-
we have the opposite. Wouldn't it be different? Right? That's where you're going at?
Basically, yeah. So what's happening is, if you see, like, think of this E here, right? Think of it as a Think of it if an A is like even right now.
Yeah.
Think of it if it's either empty, lambda, or it's either AA, right? Because we cannot have even. We're still talking about the first problem that we had in the class. So now where we are, when we are sending another A to the next state, this A, this will turn to OO, because if we have lambda here, if we start with lambda here, we'll have one A, right? But if we start with if we start with two lambdas, we're gonna have three A's. So these two possibilities that we have, we're still gonna end up with odd A's, right? So that's why we include this as odd. That's why we're sending A to this state. And then same thing happens if we want to send another A, we want to include it to this state that accepts even A's, right? So now, same goes to even and odd even, right? Only the left changes, because that's what we are playing with right now. We're playing with A's. We're trying to make them even. For the last problem, for the current problem now, we're trying to make them odd, right? So what we're trying to do is, what we can do is, I'm still thinking.
I mean, right now, for our problem, you want to continue with that, or should we continue with the previous problem again? Like actually starting both.
Oh yeah, we gotta remember that the alphabet is AB.
I just realized, did he miswrite this? Because it was initially all sets with an odd or even number of A's, odd number of B's, but there's
Yes.
no way to get to the final state with a lambda. So shouldn't it be AB plus, not AB star? Like I think he wrote it as AB star, but like because we didn't set it up with a lambda transition to the final one, it couldn't be, right? Like, do you know what I mean?
Yes, I know what you're saying.
Because that would be any combination of A, B, or whatever, and then also the lambda. But there's no way to like, he set it up as a DFA, it would have to be an NFA if you were to do AB star, right?
Yes,
Oh.
since we didn't include the lambda for E to OO,
Mm-hmm.
or like to E to EO. I'm sorry.
Yep.
Okay, I know what you're saying. I see what you're saying.
Yeah, what
I think
did
he just miswrote it.
I think so too, because
Yeah.
when we were in class, he was reusing that same language all over again, and that's why he put the star.
Oh, did he?
Because I remember using that language multiple times.
Yes, we did use that language
multiple times. And then let me see the other parts. We used the star, the lambda. Right, even
So do
before.
you think he
then,
just
yeah.
miswrote it then?
I think so, maybe, because what you're saying doesn't make sense.
Mm-hmm. Because it would have to be AB plus, which would get rid of the lambda.
Maybe like, so when you're doing like these graphs, traditional graphs, maybe lambda's not part of it. I don't know. Apart from that, you remember in the beginning, what do you have in yours? Because he has R1, R star.
R1 star, it is
Yeah.
R1 star. R1 star, R2.
What was the star there for? I forgot.
The star just
Uh,
means you can do it any number of times. I don't know, maybe. It's weird.
Yeah, because it says here for R2 star can on any time and any combination from after R2 star.
Yeah, but I think the star, like when we're looking at the R, like the regular expressions, it's different from
The
like
actual group.
in the language, like or the alphabet definition.
Yeah, man, I'm stumped. I don't know.
I don't know. I'm gonna send him an email about it, I think.
Sounds good.
Yeah,
I think I'm looking at the, like after the problem is done for, I'm looking at where NA is even and NB is odd, right? And I'm looking at the finished machine, like for only the two, like only two. Oh yeah, we also have to mention that the generalized transition graph has only two states.
Two states,
Final,
yeah.
that's
uh,
initial and final.
yeah, he has a star there too.
But if we see R4 is equal to ABB star A, right? Or like R3 is ABB star BA. So they include the star, right? Which means lambda as well. So is this NFA or DFA?
I asked him that. I remember asking him about it. What's like this one will be? I forgot what he said. I don't know if I wrote it down.
Are you talking about the star on the R?
No,
Oh no.
I can see it right here. So
Yeah.
the generalized after finishing the problem, so like the
Oh,
result,
that's right.
what we
Yeah.
get, if you see all the R's, right?
Mm-hmm.
All the R's include one way or another the star. Well, not one way or another. It's only when B is even.
But those
So
are the
it's-
regular expressions. Like those aren't the same as like the alphabet. Like they're the things that make up the alphabet, but like when they're in those regular expressions, like the star just means repeat it as many times as you want. It doesn't mean include lambda.
Or lambda. Okay, yeah, I see what you're saying.
Yeah. But like
But
when you
this-
have
yeah.
W belongs to AB star, that means W, like any word is like any combination of AB or it's lambda.
Or lambda, yes, you're right.
So I think he just miswrote that. I'm gonna email him though, and I'll send what he sends back in the group chat.
Okay.
Yeah, I
So
generally
how we should continue the problem? Should
We should
continue?
just continue it as he did it in class, because I don't think it like the way we're gonna
Alright.
do it's gonna be the same, but
exactly. Yeah.
I just had that
Okay.
thought. and I'm like,
Good catch, good catch. All right, so we want NA is odd, but I was looking at the language too. It makes sense or not? It does make sense.
Why is like the BB like on the actual like final thing? Why is there stars including it to it too?
Is if you check first, you check here, right? Uh, let's say if you go from EE to EO, you have to go through this side,
Yeah.
right? So you can do as many B's as you want, right?
Mm-hmm.
Until you go to the A.
That's why you put the star.
Yes.
To put any combination.
Because yeah, exactly.
Yeah. You don't want anything.
But there should be at least two B's. or
Yeah.
Two BBs. Like it starts with a two BBs in combination. Or lambda. Or you cannot do it at all.
So you can always make it an odd. And the side and B's can be odd.
Yeah. But if we follow the same thing, will it kind of like be the same? Like,
I
okay,
mean,
that's,
it wouldn't be just, but still, it doesn't have a difference.
or the only thing that could change is if we think as A, as O as, or like odd as A now, right? From like each state. Like the second variable we included as A, and this 1st variable we included as B.
We have we always be a at the moment, right?
If we say like, yeah, like this is B and this is A, right? Or, but I don't know how.
Wait, wouldn't that be BB even? Or even?
Yes. Well, think of it as this. That's what I'm trying.
How would it be A? So you can.
Because okay, this part includes just B's, right?
Mhm.
And this part includes just A's. So now when you're sending, well, for this problem, right? But let's say for this, the NA is even and NB is odd, right? Think of this as A now.
Mhm.
So NA is even, right? Should be even. So it's either like 2, 4, and so on. So 1 will be like, if we start with 2 A's,
Yeah,
if we add 1 more, it's going to be odd,
yeah.
and so on. That's it.
Gotcha.
So yeah, if we do like, but now if we swap them, right? That's what I was thinking. If we swap them, I think it will still be this. No, it will not be the same. So we start with BB,
Mhm.
and we kind of like change them and put them as B's, I believe. So
I believe so, yeah. Because you make the odd even beats the odd beats.
but we can also do this. We can also, I think the final, I don't think the final state should change. I think we can change the transitions. We can do EO OE for A's. Right? You're sending to. Do you guys have any thought? Kind of, I literally got stuck.
I think it's just the opposite of what we did in class. So you have, you should have the B's where the A's are and the A's where the B's are.
Okay,
Yeah.
yeah, that's what I was thinking. But does it make any difference?
Yeah.
Like on how the transition happens?
Would like how the GTG is formed?
Not on how GTG is formed, but like, I mean, yes, technically, because I was thinking, let's say for NA is even and NB is odd, right?
Mm-hmm.
We're doing the transition between EO and OO,
Mm-hmm.
and we're focusing that we're thinking that E is like this E and this O here represents the A, right? Because that's what is changing between these two transitions, which means we just send in A's, right? But what if we make it NA's odd, right? It'll still stay the same because you're still sending it to a odd state, right? Unless you are thinking that this is A because this is the final state. I mean, okay, yeah, I see what's happening. So if this is the final state, that means that this is the B and this is the A. Because what we're saying is for the final state that the final state should be that NA is odd and NB is even, right? So in this state, the final state, what we're doing is something is even and something is odd, right?
So then, based on that,
Oh, you would just
we would
reverse
already know
even
the
and
final
odd.
state.
Exactly.
But
Yeah,
it doesn't matter really what they're labeled. I mean,
Of course.
I guess it does, but like it doesn't, you know what I
It,
mean?
it does with like following the path where you're going, but it
Sure.
doesn't matter. It doesn't matter like of functionality base. It will still work the same.
So
Mhm.
then the final state would either between like OE or EO. It can be OO or EE.
Exactly, because that's what it's asking, right?
Yeah.
It has to be only either OE or EO. But okay, we gotta keep this in mind then. Just like, yeah, just trying to find the final state. on whatever the restrictions are. So if it says A and A, NA and NB are even, it's just gonna be, this is gonna be the final state, right? If NA is odd and NA,
Where
NB
if you
is
put, if you
odd,
put both even, you mean?
if you put both even, this is gonna be well,
Can it be initial and then like,
I was thinking that.
but I don't think the initial will begin as even. We'll probably do odd as initial.
Then you just do odd, right?
Yeah, and then you just
Yeah.
put even
As
on the
initial
other
state. Yeah,
If they're
Makes
both
sense.
gonna be even or they're both gonna be odd, like in the language, is that what you mean?
Yeah,
yeah,
Then the graph would look completely different.
yeah, exactly.
yeah.
But
I'll
like,
probably
if you
do
just
this.
want to swap them backwards here, if you just move EO from the bottom to the top and OE from the top to the bottom, you can keep the final state in the bottom. And like, you can
Yes.
have from E,
Yes.
yeah. Or
Yeah,
you can just leave it as is and like consider the
swap the
first
left
one
and
to
right.
be B and A. I mean,
Oh, you know what? Yeah, that's.
I'm probably gonna do this when the actual exam starts. I'm probably gonna I'm gonna keep the final state just how it is in the actual question.
EOE. What did you say? Sorry.
For example, how it says odd even, what's in our example right now, I'm gonna put the final state where how it says it.
Okay, yeah, that's smart.
Just follow it, just in case.
So I just changed the final state here, basically. I'm gonna remove this. We're gonna draw them again, but
Yeah.
all right. So let's start. Right?
Make
NA
it a
is,
little bit bigger.
can you guys see it?
Just make it a little bit bigger so you can have it more.
Oh, okay, let's make it bigger. We have time. Okay, we got 30 minutes. All right, we got time. We got time. This is my first time like doing this, by the way, guys. Sorry if I'm being all over the place. I'm kind of aware,
We had odd, right?
but I cannot help it. I think with practice I'll get better.
No, you're good. It's helpful.
We had odd, right?
Yes.
Even.
Yeah.
And then
Odd.
Even.
Even. Yeah.
We could just make the transition a different color to be easy to identify.
So just so like all are in the same,
And would you say it's a good practice since we know how they would look like based on how he did it?
Yes.
Would you say like it's good to just redraw the arrows? Or you say it's not a good idea?
No, I was gonna say which one should we include
Or
as the final state, just for you.
Oh, I would say just for the sake of it, just always follow how he did it. Just in
for
case.
this problem, right? NA is we
Odd
can.
even, so we just put this one as a final
Okay,
state.
I'm gonna put this. So,
Yeah.
Okay.
Just for
Okay.
the.
Can you do it?
Yeah, I'll do those.
All right. So A B A E even A. So this means that odd. Okay, we're still sending A here, right? That's basically what is happening.
yep.
Well, still the star is kind of like messing me up.
Just ignore the stuff more.
Okay.
Because you won't have to worry about that. Only won't have to worry about that.
Okay, just gotta think. N has to be odd, meaning that there's always gonna be one N, right?
Mhm.
So if there's gonna be just one, okay, yeah, okay, this is good.
It will still be A, it wouldn't be B.
Well,
But you're taking the evens to the odd.
N is, well, the reason is because. Okay,
No, it's right. Oh, it is.
because the final state should be always one, right?
Mm-hmm.
Like start, because it's odd.
Yeah.
I'm talking about A.
Yeah.
So when we start for the initial state, we need at least to send one A there to make it odd, right? Because right now A is 0, which means it's even, right? We're trying to make it odd.
Gotcha.
So that's down for the final state. And the reason E is even for like in the beginning is because we still don't have any B's, which means that B is equal to 0, which is odd. 0 is odd. 0 is even. So that's why this works.
Okay.
Okay. And let's go to the other. Okay, let's try and go from here now.
Yeah, all we need to.
So we send in one here, right? If we send in one here, the right side is changing. So B is becoming odd. So we are adding a B here. So we're adding B's over here, right? And then we follow through odd, odd, right?
Even.
So what is happening here is, let's say we start here from the beginning. So the beginning is 0, 0, right? So it's empty.
Yeah.
And then it will be A. It'll just be A, right? We're only going to do one. We're trying to make one loop with like one full loop, like one circle, just
Yeah.
like the least transitions, right? So right now it's A and then no B's, right? And then we send another B, that will be A, B. So now it's, when we are in this state, remember, we're doing only one cycle, but with the least transition. So we just don't include this two, right? This and this. So now we go to the next one, right? We're going to the next one. It makes A even. So we send in A here. And it's not changing the B. So now it's A, right? And then we send in, what we're sending here, we're changing B to even. Now it's odd, so that means we're adding B. So it's going to be A, B. It's the same. I just like wanted to keep track of it.
So we still have the same as the other homework we did. How we did in class.
The reason it's going to be the same is because we changed the final state. If we didn't change the final state,
It would've been different.
it was just going to be completely the transition. So what we did here is we changed the final state instead of the transition.
The B's would have been here, the A's would have been here.
Yes, because if we change the transitions, it would be much
Yeah,
more
okay.
complicated. Well, it would be kind of like simple, but it will be complicated, like
Exactly.
from the last problem. We wouldn't keep track
So,
very well.
so then this would have it when they go back, they would have the A including itself, so it would be 3 A's and 2 B's.
No, it's 2 A's, 2 B's because it's EE. It cannot be 3 A's and 2 B's because it's even.
anyways. Okay,
No, I don't want to be even. I want it to be odd and even. That's why this is not a final state.
That's what, that's what I meant at that point.
Yeah.
Gotcha. Well, so when they go to there, they would go odd.
Yes. And we got to include the things. I recommend we include this even in like the files for each thing.
Yeah.
I recommend.
Then what was, I missed the point where he connected each state to themselves with, is it lambda?
No, it's 5.
It's fine.
So
What is-
5 means like,
This is not phi, this is empty set, or is that phi again? These ones, this one again.
yeah, it's basically like,
Phi.
it's not lambda. It's not, it's something like, hey, this doesn't work. This doesn't exist for.
Oh, that's what it means for?
Yeah,
Okay.
I think so.
Right? Okay.
Because what I'm like, how I'm basing that statement I just said is, remember when we were doing like DFA minimization, and then we would sometimes like or not DFA minimization, let's say NFA transition to DFA, right? We'll end up with like with phi's when we were making the table, right?
Yeah.
So that's how this works as well, because
It's probably
for the sake of this,
process.
yeah. This is always in relation with the language.
Yeah.
I haven't experienced any other language because even professor said this is the only problem in the book for this type of example.
Yeah.
This is the only example for this type of problem in the book.
There's a high chance we're gonna have the same question anyways.
Yeah, but just probably different like
Different,
different restriction. But I think it will be the same. We can have the same. I don't think there will be the same alphabet because it will just be more.
Oh, you don't think it's gonna put AB?
I don't think there will be more elements because it will be
Will it be no? It'd be
more
huge.
more
More expensive.
more.
Okay, somebody asked in class and he said it wouldn't get any bigger than like 4.
Yeah.
Yeah.
Yeah, so we don't have to worry about that. But I'll remove this because I don't have much space from the other side. And thankfully we have them in our
What is
notes.
probably, yeah, no, it's still low. Okay, that's good.
Oh, we have it on our notes, so we can like kind of like look and then
Just recording.
yeah, it's also recorded. So
Show it down in the notes.
So now what we need to do is we'll do
Okay,
E,
guys,
O, E.
thanks for the help, but I have to step away. I wanted to ask if you guys are gonna do this again at all. Or no plans as of right now.
I don't have any plans.
Okay,
So
okay, just wanted to
I have
double
the-
check.
yeah.
Okay, thank you.
Always good. Have a good one.
Yep.
So EE, sorry, I did EE, right? Even. Yeah. Even. OE, double. Remember, this was the final state.
Yeah, so
OE was the final state. But let's try to deal with the EO first, right? That's what we want to get rid of. We want to get rid of it, right?
okay, because I was thinking like how he did it, that's why he put it in the final state.
So think about it. You're sending A and B, right? You are sending A and B or B between this let's say this was yeah, I shouldn't have removed it, but it was EO, right?
Yeah.
So we're sending these, right? Names. Believe so, right?
Yeah, we were sending A and I was sending B there, like that.
So we just, since this is not a final step, we kind of like remove it. And do it ABA. Doesn't matter.
Oh, gotcha.
And goes the same thing for from OO to EE. It's not the final state because we need NA is odd and NB is even. So now we go to the final state, which is OE. So we still keep it the same. A. A, B, or B, no, it was BB, sorry. BB, because we changed it. BB.
Yep.
Yeah. Yeah, just to make sure we want even Bs. Yeah. So now we're trying to remove this one, right? I believe so.
Loop it with BP star. A star.
So how this works is we can go two ways to like back and forth, right? From E to OO, I mean. Or no, we should think of it as this, right? So A, B, and B, right? So we can either choose, we can choose 1A, right? We can choose 1A. Then it's going to be A even. And B, how does this work? Do you have any thoughts, Parker?
Sorry, I was looking at my notes. What are we? Sorry, I don't mean to be.
So
What are
yeah,
we?
we still trying to generalize the machine.
You guys are missing the loops back on themselves for one.
That's sort of the point we're at right now. Should it be BP star? Ooh. Wait, right?
No,
Yeah,
like
right.
from when we removed the first one, there need to be.
Yeah, you're right.
Mm-hmm.
Okay, I'm mentioning.
I thought I was talking about that. It should be BP star, no?
Sorry. No, those are just AAs. So,
A is
well, this one not AA, it's BB, right? Because we want even B's, right?
I was doing mine the normal way. I didn't write it down, the way you guys reversed it, but yeah, yeah, EE, yeah, it should be BB and the other one should be AA. And then the
Yes,
final
yeah.
state is still just,
Theta.
empty. Yeah,
Yeah.
theta.
What was it?
Phi?
Phi.
Phi
Yeah,
is
phi,
phi.
yeah.
Phi.
I
Phi
was
is
getting my Greek letters mixed up.
yeah.
You know, tell me how you say in Greek.
How do you say this in Greek?
Sorry, it's like epsilon, like that.
But epsilon, I thought it was this. Right?
Yeah, it's right. I don't know. It's weird. Theta.
No, theta is this.
Theta. That's different.
Oh, there's two.
Yeah, they're the same thing.
God damn.
Yeah, I'm still looped. I don't know if it should be from E to O. I don't know if it should be A B or an A B because I'll see here in the notes. It's kind of like how from EE to EO and then to OO, it goes from to BA, and then it takes it back to from OO to EE, it goes BA. You know?
Yeah, it is. He's right. Because the order matters.
The order does matter. You're right.
Yep.
Since we did BA, so the bottom one from EE to O should be, so like this should be BA. And then
Why does the order matter?
Because
that's
you
how
have
the
to
input
go, like, the transition, like, you're gonna go first
'Cause you're going in a
over
loop,
B and
you
then
know?
back on A, yeah.
you're going, it goes to the final state and go back, and then from O it goes back. You see here, it did,
Yes.
it goes back to
Make
BB.
that-
And then from EE, it goes from here, A to B, and then AB.
Makes sense. Okay, BA. So this means that it will be
BA.
BA.
No.
Should be B.
Yes.
BA because
Yeah, BA, and then from the top one, EB. Yeah, so that right here, BA and then AB. Make it to the bottom, so. You know,
yeah, you're right. I was gonna use another color for
Yeah.
that.
Let me do it.
BB. AB. Yeah. So from BA, that means like, okay, BA, we have one B and one A, and then we're sending one B here, we're not sending A's, that means there will be two B's, which will is even, and then one A, which is odd.
Yeah.
Mm-hmm.
All right, makes sense, makes sense. Okay,
Then we have the two loops, and
so now we're trying to, this is BB because it's, they're even. This is AA because we need both of them odd.
I think this one's done, no?
Oh, well, yes, now we
Yeah,
have to,
we're in the second state, yeah.
we're in the second stage, so.
So in this, we don't include the stars, right? Since we're basing on the issue, or like the language that he did. Or do we still include them?
There will be stars this time.
Yes, this will be stars this time because of the loops.
Okay, so
Mhm.
AA star and BB star
Yes.
will pop.
The reason is because these loops, you can decide to not,
Yeah, go to them.
yes, which is pretty interesting.
So should we add them? We add them, right? Or no?
Yeah, but we have to make like another machine. We kind of, because
Yeah, we have to
this
make
is
that-
going to be removed.
Yeah, it's gonna go from initial to final.
Mm-hmm.
Right? That's the final.
Yes,
that's the final.
yes.
Well, in the exam, we don't have to right here, we would have to put the stars, no?
No,
No.
Not
it's
here.
kind of weird, not here, but in the next stage you will.
Yes.
Okay, because basically, so we won't go by the notes, just by basically if you put down mistake then, right?
Yes.
Okay, gotcha.
It's basically, I think, because the first time when you do it, you're not transitioning on one of those loops that's like, so like if in the first one, if it wasn't, is it phi, right? That symbol?
Yeah.
If the loop back to EE or any of them hadn't been phi, you would have a star. But because there's nothing there, there's no star, and you're just going like from like one path
Gotcha.
that's A and then the next one's A. But like I believe if there was something there, I don't know if we did one like that. Maybe the one we did with 3 had something. I can't remember. No, it was just
So
Yeah.
it won't be like a thing like you actually have to worry about in the exam, right?
Oh.
I doubt he's gonna put something like that.
yeah, probably
know,
not.
well,
I don't
first
think
of-
he's gonna try and trick us or anything.
Yes,
I think it'll be
Hopefully he
this
emails it,
exact
no?
problem. Yeah.
that is true.
Because I doubt it. He doesn't answer your email. So it took me like a legit like 2 months. I had to go in person for him to get a response back.
That is very
So we have to go before him before he enters class and ask that
Yeah.
question.
We don't have
That's
to leave
fine.
the States.
I did email him about something yesterday and he got back to me today, so.
Okay, that's good. It's
Actually, let's put it here so it makes it easier in sense.
Okay.
We'll move this.
okay.
The TA is horrible. She never answers.
I haven't emailed her.
I had to
I'll
email her
keep
2
that in
times.
mind. About
Okay.
homework.
For the example, the homework assignments, make sure you put it all in PDF. If you put like different images, you might skip them.
So we have to keep in mind what we raised, actually. It's kind
I
of
mean,
like
we kind of have the same thing.
similar, but yes, so we just have to remember that this one was BB and the other one was AA,
Yeah,
right?
yeah,
It
so-
was B. So now when this is going from here is AB and then yes, so AB
Yeah.
and then you have AB.
Oh no, wasn't it BA?
BA was okay, was it
I
BA?
have
Yeah,
it
was
if you, I can see everything. If you want to redraw the second one and also draw this one, that might be easier. I don't know.
Yeah, we draw the first one we did over there.
Yeah,
Did you write it?
What?
I wrote it down. I can.
Okay, that's
Oh, yeah,
good.
yeah.
You don't remember? I got you.
It was kind of like, you know, like so many arrows going everywhere.
It's 6 arrows in total. I remember. I still remember.
I think I do remember.
There you
I just like it's hard to visualize
one's
it while
BB.
doing the
go.
other.
Yeah, I feel you.
For sure. That one's AA.
This is
ABA and then ABA on the top. And these were A's or B's? I forgot. B's. They were B's.
Yep.
Yes, and then A's.
Yep.
Perfect. Six arrows in total. Yes.
Yep. It's all good.
Just need that. Oh, yeah. All right. So right here you were from EE to OE.
so we're going BA, AA star,
Yeah.
and B, basically.
Yeah.
So BA,
Look, isn't it supposed to be B plus
Yeah.
EB?
There's it's A plus in this case.
Oh, it should be
believe.
from from EE to OE should be B plus, A plus.
From, because you can go straight from EE to OE with an A, or you can go with
Yes.
BA, AA star, B.
You have to see it here.
Yep.
So let's do this, and there will be a top here, not a bottom.
this is A plus. Okay, I see. A plus, then BA,
BA.
and AA star.
Then B.
Is it not outside the parentheses or inside?
Outside.
It's outside.
And then what is it? BA again? Or what was it?
Just B,
B?
because you're
Yes,
at
it's just B
OO and then
because
you
you're
just
just
have
going
one
up.
B back. Yep.
Okay, gotcha. What was the difference in the exam from the homework that he made it?
I did not see the home.
Because in the homework for when he goes from EO to EE, I mean the assignment in the lectures, I put BA, B plus A, BB star BA.
Yes,
Is that
So-
right?
yes, that's how it went. You have to think.
Oh yeah, because it had included the missing state, the removed state.
Yes, exactly. So that is gonna happen the same thing
Okay,
here.
exactly. So we're gonna have AB there.
Yes, so we're gonna have. Where's this going? Oh, this way.
Yeah.
The arrow on from EE to OE, the bottom one should be the other way. On the second, the new
Yeah.
picture.
Oh,
Like yeah,
Oh yeah.
yeah, it's just that just, yeah, he sees it.
oh yeah, you're right. That was-
Oh, I was right. I was right. Okay, that was true.
So now we're looking from OE. OE is the final state.
So we have to go from OO. So
You can do A plus.
Yep.
A again. A plus.
oh, I thought it would be going like through here, or is it going directly?
Well,
to because I based it on the
We're
No
doing
homework.
all the combination, all the transitions we
Yeah.
can do. So we can either do A
A, then plus, or, then, and,
plus, yes,
B,
B,
A,
A star.
or is it AB?
I think it's
It's
B,
just
A
B.
star.
Yep.
B, A star, and then B,
Then,
A, B.
AB.
Or
Yep.
AB, yes, AB.
Still,
Right?
am I missing something?
You have to do the loops like on EE and OE as well.
Right there?
Yeah,
BB.
that changes as well. Because
This
it's
one.
like, it's
Oh, yeah,
how,
yeah,
it's
yeah,
how
yeah,
you
yeah.
can get back to EE, right? So you could either do BB or you could do, BA,
Yeah.
AA star AB.
Oh, I didn't see those.
Yeah, I forgot
Yeah.
about those.
Okay, oh, I see now. Okay, that's why I was getting confused.
Yep.
Okay. Okay,
So we have here. What is that?
so it's gonna be BB plus,
Mm-hmm.
it's gonna be A plus, right?
Yeah.
So BB plus, it's gonna be,
Do you see Parker this one? Oh, you can. Yeah.
That one is,
It's blurred by the line.
that one should be BAA star B.
Oh, for OE? It shouldn't start with AA?
Because OE back on itself, remember OE doesn't have anything, it hits a 5.
Yeah, it's in it's a
right?
5.
So there's nothing, so there's just one term. But to get back to itself, you would go B, AA star, BA, or wait, no, sorry. You do B, AA star B through OO.
BAA star.
Yep.
B.
Seeking
Back to.
The other one should be BB plus BA, AA star AB.
For R2, what did you guys get on the original problem?
For R2, which one is? I got B plus AB, BB star A.
So I'm trying to figure that out, how that's, okay, B plus AB. Is your transition of AB going from, like, how is it pointing? Is it pointing to OO from EE, or is
Yeah,
it pointing? Okay, I've messed it up. I put different ones. That's why I got confused.
oh,
I
okay,
noticed.
What
gotcha.
were you talking about? Because
No, I was just looking at my.
what you were talking about? Because I didn't follow with you guys.
Let me get my pen. No, so you see how the R2 is B plus AB, BB star A, right? So that,
Oh.
so what I've done here is, right, it's B plus, right? It goes
Yeah.
to the final state. Or you can choose AB, but what I've done is I've pointed to EE, right? But it's not supposed to be, should be from here. Because that's where it's pointing, right?
Oh,
So
gotcha.
AB,
Oh, I see your mistake. Gotcha. Make it with another color. So you can see. Yeah, I got it. Yeah, but sometimes you miss this.
BB star A. No, because I was trying to solve this one.
And then you're just looking at your
Yes.
notes.
I
Like,
was-
what's going
It
on?
doesn't make sense. So that means,
It's perfect timing.
that means BA, BA, AA star. Oh, you did that.
Yeah, right here. So B and
Okay,
star.
Oh, you guys are, or wait. Oh, I think it's just the glare. I can't see it. But
So
yeah.
now is it BB? Is it?
Yep.
Okay, it is BB.
No, you're good. Don't, I have it written down. Don't worry about it.
So BBA.
Oh,
Now I
Oh,
can't
see.
see.
I did something wrong. I'll try to make it bigger so I can see the reflection so I can hide it.
Oh, no, don't worry. I got it. I just thought the arrow wasn't there and that was why
There we
I
go.
can see now. Cool. Yeah, so it should be BB plus, because BB
BB.
just loops back on itself, right?
Yeah. Yes. And then it's gonna be
Then it goes to
It's gonna be B. A, B, A.
It'd be BA, AA star B.
Yeah, so go from the
Because you're
bottom.
just
Oh,
going,
yeah.
you're going from EE through OO back to EE.
You're going from E to O, yes,
Yep.
sorry. I do not, I
Nope,
was
you're
from
good.
the final state of the thing. Alright, I'm so tired. BA, AA star. Alright.
This is long one. And then,
B,
Or, wait, AB.
wait,
sorry.
no, you went
AB.
to OE, you didn't go to EE.
It should be AB, yeah, at the end.
Yeah, it should be AB. 'cause
From
you
OO
went
to
from
OE.
here, you went to OE, you went to the final
no,
state.
BA, right?
Yeah.
AA
Mhm.
star.
And then you put B to OE, we're supposed to go back to EE. So we put AB. Cause you're going,
You're
Yeah,
right,
you're trying to
you're
go
right.
from EE to EE.
To itself, yes, this one, by
Yes.
the way. It's trying to go from here to here.
Exactly.
Okay.
Yep.
Okay, this one was the other one that I
Yep.
was trying to do, okay,
Mhm.
alright.
okay, how come, for example, when we put the E, why don't we include how we can go from A to this way? Or is it like, it's not optimal, or is it not supposed to happen?
Can you say it again?
For example, right? Can you see what I'm pointing at?
Yeah,
Yeah, for example, I was thinking, since this is also an option too, since we're only including is like BB and then going to this way and then going back, why don't we include A to OE and then this way around, or just like this to be just quicker around, or is that part of?
I think it's because you're trying to eliminate it based on going to OO
Gotcha.
first.
Ah, that
Yeah,
would
so
make
like
sense.
if it
That makes
doesn't go
sense.
to, you go to OE first, like that's not gonna end up being part of the regular expression because
Yeah.
like, yeah. Cause
That's what I
OO is
feel like-
going away, so,
Yeah.
yeah.
That's why I feel like what you said about I don't think there should be a star since we're trying to
Yeah.
minimize it in a sense. And with
Yeah.
the star, we also include that all possible
Mhm.
methods. So I
And
think like he's actually wrong with it.
Yeah, I think the problem is just that you would need to have a lambda transition between EE and OE. Because if there was like, if lambda's an acceptable word, then you would have to go from initial to final state without any input, right? Which would make this an NFA.
I do want to
And,
see how this would look like with lambdas and stuff now.
I think it would just be that lambda, well, actually, no, I think you would have to have lambdas everywhere, right? Because technically you
bro,
could,
go-
yeah, yeah.
Insane.
right.
You know, imagine if this would have to include lambdas.
I think you
Yeah.
can, what you can do is you can include lambda to, like you can make it self loop, right, to one state with lambda. And then make that lambda point to another
Oh,
state.
wait,
Because a lambda is a free throw, right? Free flow, sorry, not free throw.
You could say that.
I don't want pointer, it's a free flow.
It'll be a little bit more messy because there'll be so many lambdas.
Yeah, but you don't need so many lambdas. You can just do two lambdas because you can point one to itself and then you can point to the other one. So you can kind of like create a bridge to the other state to kind of like make a.
Basically, you replace the phi's with lambdas.
Yes,
So it's not that bad.
only one phi.
but then you still wouldn't have
Not the
a
final state.
transition from EE to OE.
I was thinking for these three states. Let me see the four states.
Because I was thinking, for example, if you had lambda, the final thing, this one will be extra long because you'll have to include the lambdas in it.
Mm-hmm.
Because it'll be like lambda A plus like lambda something something.
Let's say
Yeah.
we have let's say we have lambda to EE, right? In the four states. And we point A to OE and then point B to EO from EE, right? And then let's say we point another lambda from EE to OO.
I have one quick question. Sorry.
Like, will that create a free flow like to every other place to like to choose between A or B? That's what I was thinking. Like how the free flow.
Explain it one more time.
So think of it as a EE, right?
What do you put them on the right?
Think of it as think of it as, let's say this EE, right? It's a lambda. And then we're pointing one lambda here.
Yeah.
We're pointing one A to,
A or lambda?
no, we're pointing one A to EO or OE. This is OE, sorry. Let's say this is O, right? So we can keep like, and then we point a B here, right? So this works as a bridge for the as a free flow because we're pointing A or we're putting B and then A and A, right? So we can choose like, we can choose B, right? Or like we can choose A, the other ones. And if we go from here, we'll go from here from EO. A, A. And play a bit early.
You know, good thing we don't have to worry about this much.
Yeah.
Yeah, it's just something
Yeah, yeah,
interesting.
good.
It's just something
Yeah,
interesting.
I was gonna ask this one. What do you define? I was just curious. Which one of these is R1 and R2? Is it the one from initial to final is R1 and then final to initial is R2? Good question. Good question. What do you think, Parker?
Yeah, I don't know. I was kind of thinking about that too. It's a little confusing because we
It
didn't
makes
keep the
sense.
same, oh,
It
from,
makes sense, man.
so the top one is R2 because like when we
R2?
did it in class, from EE to EO is R2.
How though? Because it's from initial. That's what I was thinking. You know, I'm thinking like from one to finish.
Mm-hmm.
Okay, I'll just put it R2 is the top one. The one from EO to R2. EO
Yeah.
to EO. What did you put? Did you put R1 from
From
initial?
R1 EE, yes, R4 EO.
Okay.
Also, I had a question for problem 4 homework 2, right? Did we pass it? Oh, we passed the time.
That's fine. I mean, unless
mean,
you have
okay, I
somewhere to
got
go.
Okay.
So
So let's say AA, or sorry, problem problem 4
convert the NFA to defined by
yes,
Yeah.
for the Q0, right? Do you think that could be a final state as well?
This was on assignment 2 or
Yes.
assignment 3?
Assignment 2.
Assignment 2.
Oh, 3, sorry.
What I was
Oh,
saying.
okay.
I'm so mixed with
I would say no because it's an initial state. How can you have initial state and a final state at the same place?
So assignment
so-
4, or I'm sorry, question
Assignment
4?
3, question 4.
question 4, assignment 3. Yeah.
Yeah. So what are you asking?
So could Q0 be a final state?
I say no,
Uh,
just based on since Q0 is the initial state. That's my only reasoning. Like the top of my head, without actually looking at that with that question. Pick up some other stuff.
it says initial state Q0 and final state Q2.
Remember, yeah, in the question it says which
Yeah.
one is the final state.
Well, this says for the NFA, right?
Yeah, but it says like,
So will it still stay the same for DFA?
I mean, yeah, since you're not changing, like it's not like you're doing this.
When
know
you
this-
convert it, the final states, any final state in the DFA that has Q2 in it is a final state.
Yeah, so Q0 can't even be because it's initial state. I don't know if you can have initial state and final state together.
The reason I was thinking that is because of the lambda, right? It works as a free flow for like everywhere, like a bridge, you know.
But then again,
Connects these final states, Q0, Q1, Q2, and Q1, Q2 with Q2.
but question 4 is all about DFAs, so you won't even have that in the end. The free flows are eliminated automatically.
Yes, but how
But
you
like, so the reason like, that the other ones become final states, right, is like in the NFA, right? If you just go from Q0 to Q2 with the lambda and then you have an A, like in a DFA, all you did there was just get one A and then you're at the, well, I don't know, actually. No, that doesn't make sense. Never mind. But,
I see what you are you thinking about the loop? The loop
Yeah.
from Q2?
mhm.
The reason that could not be with the lambda is because, well, we already have, I think we already have A pointing at Q2 in the NFA, right? And that other A that is pointing from Q1 and Q2 is because of the free flow with the lambda.
What did your answer end up looking like for this one?
Oh, I can write it. Here. Thanks.
It was like what Q0 to Q1, Q2, and then Q0, Q1, and then Q1, Q2, and then Q2, something like that. I see.
Let me see. I'm gonna remove this because
Oh yeah, you put Q0, A, like Q0, Q1, Q2, looping itself to A, and then B, Q1, Q2.
Oh, can I see that?
Oh, sorry, yeah.
It's okay.
We got two colors.
Let me grab some more
Tissues. Oh yeah, you have to clean. Yeah, I'll start drying it for you.
Well, let's start writing the NFA first.
Are you do the whole thing?
Well, we're kind of like trying to understand why we got here. I mean, why I got here.
Okay, there you go.
Because my point for the lambda, I'm trying to say why I think that Q0 could. But now a second thought is probably not, but
What's your second thought? You can say we still some time.
no, because you mentioned like that Q0 is initially states in the beginning, but
Let me look it up. I don't know how to look it up. I'm just curious to see what else would say.
All I know is that he said when you convert to a DFA, whatever final state or whatever states in the DFA include the final state from the NFA, they are final
it'll be a
states.
final state.
Yeah.
But the thing is, Q0, Q1, Q2, Q0 is in this state that Q0 and Q2 are together, right?
Mm-hmm.
And I was thinking, if that's a final state, why not Q0 alone could be my final state as well? That's what I was kind of confused about it.
Yeah, I'm not sure. I get what you mean because like technically if you had nothing, yeah. I'm not sure. I'm
Let me
just
look it
going
up
based
some-
on what he said in class.
Yes, yes. So this is the NFA, right? And I'll make like a small like NFA here. Going Q0, Q1, pointing A, and pointing A to itself. And then we've got Q1, we've got Q2 here. Q1 is pointing B at itself, but as well as Q2 transition. Q2 then is transitioning A to Q2, making a loop. Then Q0 is doing this lambda thing, right? So what I was thinking is, can I have the red as well? I work better with red for some reason, which is it. So yes, makes sense. So I was thinking, right, when we are making the DFA, we kind of like have this making A, no, not this A, sorry. Making this A and this B basically, but this B is going to here, or this B to, well, this is going to point to itself either way. But this A specifically, we're making it with this lambda and we're sending it there, right, as a transition, but we cannot accept lambdas in the DFA, so that's how we're making the bridge, right?
I'll say this, Chad said, initial state can be a final state.
Cannot?
It can.
It can?
Yes,
Oh,
it's allowed.
okay.
I said it was based on in both NFA or DFA can also be a final accepting state. This happens when the automata is assigned to accept strings that could be empty string, or when some valid input leads to acceptance without any transitions.
See.
So a DFA example, suppose we have a DFA that accepts the empty string. The simplest way to represent this is to have the initial state also be an accepting state and no transitions are required.
Is that
The structure is valid and commonly used in automata design, especially for languages that explicitly include empty strings in the accepted language stack. And we do have an empty string.
so like let's make a table, right? Let's make a table. Let's go A and B, right? And we have Q0 here. Yeah, Q0. You have pointing A, Q0, Q1. And then nothing here. And then you have Q1. We have nothing here, but we have Q1, Q2 at B. Okay. This is how it works. This is the NFA. I'm still making this one, but Q2 as Q2 phi, and then Q0 has this lambda as well, which I'm just including just because for the sake of it. Oh, I cannot see.
You can't see?
I can't see. My eyes hurt. Oh God. Oh, boy. I was like, what
Oh,
is
I
happening?
just realized I did this wrong.
I was like, oh, I'm getting blind. I got scared for a
I
second.
have to go home and rest them. Get some good night's sleep.
So yeah, right. Let's say this professor did not include this type of thing.
Yeah, he did put lambda, yeah.
But let's say we did put lambda, right? And then let's try to transition it to a DFA. So to a DFA, that would do. We do Q0, right? We do Q0.
Well,
All right.
Q0 with A, you'll still end up,
Q0, Q1, Q2, right?
well, even with Q0, if you do A or B, you're still gonna end up in Q2 because you have the lambda.
Exactly. Correct.
Yeah, in the NFA table, you don't have that, right? Or is it because you're putting it in the third column?
Yes, I'm doing what is happening here. Like what is happening here? What I got from this, I'm putting it right over here.
Right, but like for Q0 under A, shouldn't it be Q0, Q1, Q2?
You're right.
And then for B, it should just be Q2, right?
Well, the reason I'm not doing that is because you're right,
Yeah,
but it's
it's
because of the
because you're
lambda.
putting it over there.
Yeah,
Okay, I just want to make sure.
yeah. And then when we turn it to the DFA, is that is A is going to be Q0, Q1, Q2, right? And then B is going to be, I believe, it's going to be. It just doesn't have any B's, so he's just going to do trap, right? He's just going to send it to a trap. Don't confuse it with the Q1, the Q2, because why? Because why? Why not confuse it with it?
Well, because Q0 isn't going to go to a trap when it's B in DFA.
You said he's not?
No, because it's like
It's
it'll
a
go
free
to Q2.
two, yeah. Well,
Because you only get the phi if there's no lambda transition.
yeah.
So you think you're getting closer to your original thing, saying Q0 is an initial final state as well?
I think it's another. I came out to another issue of how Q0, like in the DFA, it's not pointing to a trap for the B, but it's with a B, but it's pointing to Q2 because of the free low. The reason that cannot be is because I don't think we are changing the transitions. Okay, let me rephrase it. I don't think we're adding or removing more transitions, right? We're keeping the transitions the same. We're just changing kind of, or like we don't change the direction of them. Or are we adding anything? Because what I'm trying to say is, sorry. What I'm trying to say is Q0 never has a B, right?
Right. But
So
it has a
how's-
lambda. So even if you have a B, it goes to Q2. That's just what he said in class.
let me check some
Because
other-
like if you give nothing to Q0, I don't know exactly, but this is like what I made a note of it.
I'm looking at my notes as well.
I'm looking to our YouTube videos. I'm sure. Always gonna have at the home.
It's gonna take a while to upload.
Why don't you do it here? So you have to test the Wi-Fi.
I will do it here.
Yeah.
I'm gonna eat as well. I haven't ate like in the whole day. I've been like with only fruits.
You doing good,
Vegetables.
bro.
Yes, that is so funny. Actually. But let's say, for example, right? What example he was like he did before? Trying to look like trying to look at any other examples that he did. So let's say Q0, Q1, Q2, right? It says initial state Q0, final state Q2. I'm looking at one of the notes on one of the problems that Professor went.
Mm-hmm.
And what he's doing, I remember that I kept note of it. It says when you're converting to the DFA, and if Q0 is not pointing to anything, right? With a B, respect with B,
Mm-hmm.
then you leave it to phi, right?
So like if you had, yeah, let me see is this the, right, so this is the, yeah, so that's right, but like when you go,
Oh, but he's not pointing
for
lambda from
it's
Q0
not pointing
to
lambda to,
Q2.
yeah, but like you see how
Right.
Q1 is pointing to Q2 with the lambda, but there's no A transition?
Yeah, so that's Q2. I
So when
see.
we have but we had a Q2 there for A, right?
Makes sense. So this is Q2. And
Yeah,
this is phi. Okay, now makes
yep,
sense.
yep.
Now makes sense.
That's what you had written, right? Like in the
Yeah,
box
but with
for
the lambda, with the-
Q1A, you had a Q2, right? In the one you were
Yeah.
just looking at,
Yeah.
in the example you just showed me. I just
Yes,
want to
that's
make
what
sure
I
we
did.
aren't.
That's
Okay.
what I did.
Can I see it again? Yep, yep. Yeah, it's weird, but it goes through even like if you don't have that, if you have the lambda, it just,
So it's not a trap. The trap will be at the Q.
yeah, the
So-
trap is if there's no lambda transition and you don't
Yeah.
have the letter. Yep.
So this will be Q2. But will it also be Q0, Q1, Q2?
Yeah.
Because lambda
Mhm.
is a free flow. That's a
Yep.
tongue twister for me.
Yep.
Yeah, so and then we bring Q0, Q1, Q2.
Oh, wait, for not in the DFA state. Hold on. This was number 4.
Number 4. Yeah,
Q0 for B in the DFA graph is just Q2.
it's just Q2.
Yeah. Because in QA is for in the NFA table for Q0, A is Q0, Q1, Q2, and B is just Q2. So in the NFA table, it's just Q2 for B because we're not looking at like multiple levels, so there's no combination. Do you know what I mean? Like when you look at Q0, Q1, Q2, like in the next step, you're going to look at like what A is in each of those states and then combine them.
Okay.
You remember like it's hard to it'd be easier if I was there to like point.
Uh, yeah, we'll go through it and
Does it make sense?
I'll
Okay.
probably catch it up. But
Yeah.
I'm understanding why this is just Q2 because
Mm-hmm.
with this lambda transition kind of thing as it can turn either to B or A. Kind of thing,
Yep.
right?
Yeah,
So
but
this
you
one
can't get to like you can't get to Q1 with a B and you can't get to Q0 with a B.
Yeah. So you cannot do this.
Right.
Okay, makes sense. Which one do we drop it now though? We drop Q0, Q1. Okay, we have to drop Q0, Q1 first.
Yep.
So we do Q0, Q1, Q2, Q0, Q1, Q2, A. It's gonna be Q0, Q1, Q2 again.
Yep.
And it makes sense. Yeah, it makes sense. And then at B, it's gonna be Q1, Q2. And then
Yep.
Q2. We drop Q2. Or should we drop Q1, Q2 first? Should drop Q1, Q2 first.
Yeah, that's what I did. I don't know if it really matters, but
I remember he said something about ordering, like as soon as
Yeah.
he said something like as soon as you get a new state, you drop it. Oh,
yeah, that makes sense. I mean,
Yeah,
yeah.
but it's a new. This is a new state. This is not. So okay,
Hmm.
I'll drop this one Q1, Q2 first. I'll probably do Q2 as well. Like see if it's gonna change. I don't think it will change anything. Honestly. Q1, Q2. Q1, Q2 is just Q2 for A. And then Q1, Q2 for B. And then for Q2 is going to be Q2,
Yeah.
and then
Q3 or trap.
this is gonna be the trap. Yeah. And then Q1 is just disassemble.
You need to drop the trap too. And the trap just goes back to itself for A and
Yeah.
B. Yeah.
Oh yeah. Oh yeah. Thank you for reminding me that. You
Yep.
also we also have to do that and then pointing to itself.
Yep.
Yeah. I usually do this with an extra state. I do Q3.
Yeah, that's what I did too.
I usually do this, but for the sake of like it's gonna be posted on YouTube, just putting trap. But Q3 and T are the same.
Hmm.
Yeah. So let's build it. I'll probably get rid of this. This is, I don't think we need this anymore. All right. So we get Q0. And then we get Q0, Q1, Q2 point A. These are final states, by the way. Every new state that's contains the final state is a final state.
So Q0 is not final. Huh?
Let's see. No, I'm still like going.
Oh,
like,
you're still gonna.
yeah. So A, then it's going to Q2, but let's do Q1, Q2. I'm just going to do Q1, 2, then Q2. Just I don't have space. Or I can just do I can just do Q2 here. So Q0, Q1, Q2 pointing at Q2 with B. Then Q1, Q2 is pointing A at Q2. And then it's pointing A itself is pointing B. Q2 then it's pointing A at itself. And then that's where the trap comes for the Q2. When it's pointing B. And then we do SF loop trap for A and B. And the Q0 points B at Q2. Okay, this fixes it. This fixes it. Why not Q0 is lambda? Because of the B, right? Thinking. Since like now this lambda is made into like two bridges where you can kind of like go to the Q2 like two different ways. Q0, the final state. I need some water. Okay. Okay. Why did I think that Q0 could be a final state because of the lambda?
Probably just because if you look at, like, I thought the same thing once you mentioned it, like, because if you're going to the final state with nothing, with like, if there's no input, you would think that, like, in the DFA, yeah. I'm still not sure why exactly it's not, but
But like, what also like by the patterns, right? Just straight up by the patterns. What I'm thinking is, okay, since this Q0, right, is included to this state, this new state that is the final state,
oh yeah.
doesn't much make sense. But why shouldn't this Q0 be a final state as well, right? Because it includes a Q2 here. But not necessarily when you do the equivalences, they're probably separate.
Yeah, I'm not sure.
Also, I noticed that the loop, the self loop from Q0, it's removed. Which you solve it at Q0, Q1, Q2. That's why you have the loop here. Okay, and then A is over here. This is A, by the way. Right, should be A. This is, oh, sorry, this is A, this is B.
Yeah. I have a question here.
Yes.
Why does, so Q1 and Q2 should have two double loops for B? It has B here, Q0 to Q1.
This is A.
Oh, that's the difference. No, don't worry. I messed up. I mixed it up somehow. Don't worry. I'll figure out the issue. And Q2 to Q2. And Q2 to the trap. So what's the issue here? Are you worried about this one?
No, I was thinking, what if Q0 could be a final state?
So once again, what defines a final state?
So let's say, like, you want to end something, right? You
Yeah.
want to finish it if you meet the requirements or the restrictions that you want to do. Right?
Exactly. So, for example, these three are final states. Are we 100% on this?
Yes.
Why are these exactly?
So just by the view, right?
Yeah,
Just by looking
think
at
about
it,
it like that.
is Q0, all these new states that were created, right? Include the Q2, which is a final state.
Because we in the question said that Q2 is a final state, right?
Yeah.
Okay, that's one of them. Boom. So automatically those are there. So Q0 has the values of Q because it goes to Q2 directly, but then doesn't necessarily since these are final states, I have the ability to go back to them.
This is
Yeah, I know, right here. Q2, yeah. Here, so in my opinion, I don't think it's one because it doesn't have anything going back to Q0. That's one of them, you know.
yeah. That's why I just realized now.
There's like nothing going back to.
No, you're right. Yeah,
That's the only thing.
that's the only thing. Yeah, you're right.
Because the Q0 doesn't even have a loop.
But it could be empty, right? It could not start at all.
That's
what I
one
was
of them.
thinking.
But it has an input. See, if we
Yeah.
if we put an L star, maybe. But no, that's if I'm
It
sorry,
won't
only
because
one.
it's not a
only one.
DFA.
Then if we had L star, we can only have one final state. Can have
That
multiple.
is true. Yeah.
But let's actually wait. If it's L star, Q0 could be the only final state. But then again, we can't because
Q0, Q2 is final state because we are assigned it at the problem, right? But it doesn't matter. No, it doesn't make sense because, as you said, right, the machine is waiting for an input, right?
But then I asked ChatGPT says Q0 can be an input, the final state.
As a DFA.
Yeah, DFA or NFA.
I mean, NFA, yes, kind of makes sense, but DFA.
Unfortunately, we're gonna have to go.
Oh, okay. I probably will get as well. So.
Yeah, probably late, but we're gonna have to have a 40-minute drive home.
Yeah.
So
I'll just call it a day. Do you have any like final thoughts for this issue, Parker?
No, I tried looking online too and I couldn't. Cause he taught us this like differently than a lot of the stuff online. I'm not exactly sure like what they're doing.
That is true. He's right. All the sources online are completely different.
Yeah, he said it too in the beginning of the class. He's like, I teach it very different from what you're gonna see online, so pay attention in class.
So I don't know if that's good or bad in real life.
I don't know.
Find out.
Maybe we know some other stuff that are not teaching online, you know?
That's what I'm open for, you know? That's always open. Open always for the positive.
It's just so hard to visualize when it gets complex. It's very interesting. You gotta have your mind like,
Bro, once you have anything, you're cooked.
what was that?
You have anything, you're cooked.
Yeah, I haven't eaten.
You're not thinking about. Take a picture of this right now and then attack it in the morning. It'll be probably better.
Yeah, I fixed something actually. I just realized where to point B, not to the trap instead of to the.
All right, well, I'm gonna head out. Thanks for doing this though.
Yes, yeah, no
It's
problem.
very helpful.
Maybe.
We might do again.
Yeah, maybe. It's very rare because I have other assignments to do and will be. The other assignments are pretty intense with my computer graphics professor. You already know. 1 second, let me.
Are you gonna take a month?
I just think the light was.
All right. I will
Alright.
see ya.
I'll see you. Have a good one.
You too. Bye.
The YouTube is gonna be crazy.
YouTube is gonna be fun. This was fun.
Make sure you put on listed, but I don't want to see my face on YouTube recommended.
Oh my God, 2 hours and 45 minutes.
Yeah, bro.
I look so tired, bro.
Imagine there's cops waiting, bro. It's like,
That's. The recording.
imagine when this there, and then the kids are like, "What the fuck is this?"
Stop recording. Wait, so when you stop recording, it automatically saves, right? You don't have to do anything else.
I don't know, but I'll use Teams.
Find out.
Yeah.